Welcome to the video on linear equations. So linear equations can be written in several different forms. The first one that we'll learn about is gradient-intercept form. It's also sometimes called slope-intercept form, and it's y equals mx plus b, where m is the gradient or slope, and b is the y-intercept. So it's slope-intercept. And that's why it's called slope-intercept form or gradient-intercept form. Next, we have general form. So the general form is when you have ax plus by plus d equals 0. So it has everything on one side of the equation set equal to 0. So for this one, your gradient or slope is going to be equal to negative a over b, and your y-intercept will be equal to negative d over b. And you could figure that out by solving for y. So you would subtract ax and d from each side. So you'd have by equals negative ax minus d, and then you would divide everything by b. So you get y equals negative a over bx minus d over b. So here's your slope and your y-intercept. Finally, we have our point gradient form, which is also referred to as our point slope form, and it's y minus y1 equals m times x minus x1, where m is your gradient or slope, and negative m times x1 plus y1 equals your y-intercept. This one is especially useful if you're given 2 points and asked to write an equation. So you can put in your y and x from one point, and then your y1 and x1 from your other point. And then you can solve for your slope. So we can figure out where this y-intercept came from. So first we distribute the m. So we have y minus y1 equals mx minus m times x1. And then we'd add y1 to each side. So you get y equals mx minus mx1 plus y1. So this m in front of your x is your slope, and this right here is your y-intercept. So you would need your x1 and y1 from a second point to figure out your y-intercept. So here we have our first practice problem. It says write an equation in gradient-intercept form that goes through points 1, negative 2, and negative 2, 4. So for this one, we're given 2 points, so the equation we'll want to start with is our point gradient form. So our y minus y1 equals mx minus x1. So we'll call these x and y, and these x1 and y1. So our y value, negative 2, minus our y1, 4, equals our slope, m, which we don't know yet, times x, which is 1, minus x1, which is negative 2. So we have negative 2 minus 4, which is negative 6, equals m times 1 minus a negative 1, so 1 plus 1, which is 3. We'll divide both sides by 3, and we get that negative 2 equals m. So now we can go back and just plug in 1 point and leave our x and y, and plug in our m. So y minus y1, which is 4, equals m, which was negative 2, times x minus x1, which was negative 2. So y minus 4 equals negative 2 times x plus 2. We'll distribute our 2 to get y minus 4 equals negative 2x minus 4. And then we'll add 4 to each side to get that y equals negative 2x. So here's our equation in gradient-intercept form. So our slope is negative 2, because that's our value here before the x, and our y-intercept is 0, because there's nothing being added here at the end. So as a coordinate, our y-intercept would be 0, 0. So next we have perpendicular and parallel lines. So perpendicular lines are 2 lines where they intersect and form a right angle, as shown here. So their slopes are going to be opposite reciprocals. So for example, if one of the slopes is 1/2, the other one, you would flip it So it'd be 2 over 1, and it'd be negative. So that would be m1 and m2. So our m1 times m2 equals negative 1. And here's another example where they're opposite reciprocals. So your 2/3 gets flipped to become 3/2, and then you add a negative in front of it. So if you started with m1 equals negative 1/4, your m2 is going to switch to be positive, and then 4 over 1, so 4. For parallel lines, they have the same slope, so m1 equals m2, but they need to have different y-intercepts. Otherwise, the lines would be the same line. If they have the same slope and y-intercept, it's just one line. So now we have our first IB practice question. If f of x equals 2x minus 1 and g of x equals 1/3 x plus 6, A, find the coordinate where the lines intersect. B, write an equation in general form for a line that passes through the intersection point and is perpendicular to f of x. And C, write the gradient for the line that is perpendicular to g of x. So first we need to find where the lines intersect. The way that we'll do that is we'll set them equal to each other. So 2x minus 1 equals 1/3 x plus 6. What I like to do is always subtract the smaller x value from both sides. So we'll subtract 1/3 x from each side. So that gives us 2, which is 6 over 3 minus 1/3. So 6 over 3 minus 1 over 3x is 5 over 3x minus 1 equals 6. Now we'll add 1 to each side because we're solving for x. So we get 5/3 x equals 7. Now to get rid of the 5/3 in front of the x, we're going to multiply by that reciprocal, so 3 over 5, because then that will simplify to 1 on this side. And on the other side, we'll get 21 over 5. So our x-coordinate is going to be 21 over 5, and now we need to figure out the y-coordinate. So we can do that by plugging x into either f of x or g of x. So I'll go ahead and plug it into g of x. So we have g of 21 over 5 equals 1/3 times 21 over 5 plus 6. So we can go ahead and simplify the 21 and the 3 to a 7 and 1. So we have 7/5 plus 6. So with a common denominator, that would be 7/5 plus 30/5, which is 37/5. So that's our y value. So the coordinate where the lines intersect would be our x value, 21 over 5, comma, our y value, 37 over 5. So now we need to write an equation in general form for a line that passes through the intersection point and is perpendicular to f of x. So we'll start by finding our slope. So our slope is going to be the opposite reciprocal of our slope for f of x. So our slope for f of x is 2. So the opposite reciprocal of that is going to be 1 over 2, and it's going to be negative. So that'll be our slope. And then we'll use our point from the previous answer. So because we have a point and slope, we're going to use point gradient form. So y minus the y value, 37 over 5, equals m, negative 1/2, times x minus our x value, 21 over 5. We'll distribute the negative 1/2. So we get y minus 37 over 5 equals negative 1/2 x plus, because we have a negative times a negative, and then we'll have 21 over 10. We can then add 37 over 5 to each side, which is the same as adding 74 over 10. So we get y equals negative 1/2 x plus 95 over 10. Our 95 over 10 can be simplified by dividing the numerator and denominator by 5. So we would get 19 over 2. So y equals negative 1/2 x plus 19 over 2. So our equation needs to be in the general form. So we'll move our negative 1/2 x plus 19 over 2 to the other side by adding 1/2 x and subtracting 19 over 2. So we get 1/2 x plus y minus 19 over 2 equals 0. So there is our equation in the general form. Finally, we need to write the gradient for the line that is perpendicular to g of x. So our slope for g of x is 1/3. So our gradient, or slope, of the line that's perpendicular is going to be the opposite, so negative, and then the reciprocal. So instead of 1/3, it'll be 3/1. So the gradient is -3. And our gradient for the perpendicular lines should multiply to -1. So 1/3 times -3 equals -1. So it is the correct gradient. So in summary, we have some important equations. In gradient-intercept or slope-intercept form, y equals mx plus b, where m is the gradient or slope and b is the y-intercept. Our general form is ax plus by plus d equals 0, where negative a over b is the gradient or slope and negative d over b is the y-intercept. For point gradient or point slope form, y minus y1 equals m times x minus x1, where m is the gradient or slope and negative mx1 plus y1 is our y-intercept. With perpendicular lines, we have the opposite reciprocal slopes, so m1 times m2 equals -1. And for parallel lines, we have equivalent slopes where m1 equals m2, but different y-intercepts, because if b1 equals b2, then the lines are the same lines. That's all for this video. Thank you for watching.